Hello, this is Math with Beth, and we're going to look at how to use first and second derivatives to help with curve sketching, specifically rational functions. So how to use some of these new techniques with first derivatives and second derivatives to help sketch a graph. So these are the recommended steps. So some of these should be review from Algebra 1 and Algebra 2. But some of this is new from calculus with the derivatives. So first, intercepts, find x and y intercepts. That's something that we've been doing for a long time. So for the y-intercept, you're going to plug in 0 for the x. That gives us -2. And for the y-intercept, we're going to plug in 0. For the x-intercept, we're going to plug in 0 for the y. But since it's a fraction, all that really matters if you're trying to set a fraction equal to 0 is the top. Since 8 can never equal 0, this can't happen. So we are not going to have any x-intercepts. So the only one we have so far is the y-intercept. Okay, now B says to find our asymptotes. So you need to remember that for vertical asymptotes, you set the bottom of the fraction equal to 0 and solve. So in this case, we're going to end up getting a positive and a -2. But remember, these are lines. These are vertical lines. So we always have to write them separately. So here's the information we have so far. And for horizontal asymptotes, we need the rules that have to do with, is the degree higher on the top of the fraction or the bottom of the fraction, or are they the same? If it was bigger on top, which it is not, there would be no horizontal asymptote. If it is bigger on the bottom, which this is, because there's an x squared on the bottom, but no x's on top, then your horizontal asymptote is always y equals 0. If they were the same, if there was an x squared next to this 8 on top, then we would take the leading coefficients on the top, which would be 8, and 1 on the bottom, and make it 8 over 1. So definitely review your rules for horizontal asymptotes if that sounds like something you haven't done in a while. All right, C, here's the newer stuff. Find your critical values of f. So that is where the derivative is not defined or where it equals 0. So first, I'm going to find the derivative. Since it's written like this, I can rewrite it so that I don't have to deal with the fraction. So this is just another way to write my f of x. And now I'm going to do the derivative. So power rule, I'm going to take the -1, multiply by 8, and then subtract 1. And then I'm going to multiply that by the derivative of the inside. So basically this is the chain rule. All of that really gives me a -8 times 2x over this. Okay? And if I wanted to set that equal to 0 now, or find where it's not defined, I'm basically going to set the top and the bottom equal to 0 to find my critical values. So setting the top equal to 0, I get 0. Setting the bottom equal to 0, I can square root both sides. And get 2 and -2. So my critical points, my points that are possible max or mins, are -2, 0, and 2. Well, we already know that at -2 and 2, we don't have a max or a min because they're asymptotes, but it is still helpful to find out, are we increasing or decreasing on each side of these so that when we go to sketch it. So I'm still going to pick a point in each of these sections, plug it into the first derivative, and see where the graph is increasing or decreasing. So if I plug -3 in, to the first derivative, so this whole thing, it will give me a positive. If I plug -1 into this whole thing, so I'm plugging in -1 into both places that there's x's and finding out what all of this gives me. So it's also positive. Plugging in 1 will give me a negative. And plugging in 3 will also give me a negative. So just like we thought, nothing special is happening at -2 or 2, but we do have a relative max at 0. So I'm going to go ahead and plug 0 into the original equation now to find out where that's happening. And it is -2. So that is also something we've already found. So apparently our y-intercept is also a relative max. So that's good to know. So now for the second derivative. I'm first going to take my first derivative and I'm going to rewrite it again so that I can do the product rule instead of the quotient rule. So you don't have to do that, but I think it's easier to do the product rule than the quotient rule. So that is just me rewriting the first derivative so that I don't have to deal with the fraction. So now my second derivative is -16x times the derivative of this, which is going to involve the chain rule. So the -2 will come out front. This stays the same, but I subtract 1. And then I have to multiply by the derivative of the inside. Plus this part as it was times the derivative of the -16x, which is just -16. So there's a lot going on there, but you can definitely rewrite this in a nicer way. So if I multiply the stuff I'm allowed to multiply, I'd get a 64x squared, and I can move this to the bottom since it was raised to the -3rd. And same thing here, I can at least make this 16 over this to the second power. So if I want to find out where this equals 0, it would again just be setting the top and bottom equal to 0 and solving. So I think we can probably go ahead and sketch from what we have so far. So I'm going to see if I even need that part. So starting with what I have asymptotes at +2, -2, and 0. So we have all that. I have a point at 0, -2, but I also know that point happens to be a relative max. So I must be going like this. And I know that to the left of this -2, I am increasing. So it's hard to have an increasing part over here. So I could pick a point and check, but I'm pretty sure that means the graph is doing something like this. And to the right of 2, I'm decreasing. So most likely something like this. So the sections where you didn't have any actual points, you could always take an extra second and plug in something like -3 to see exactly what you get, plug in 3 to see exactly what you get. But just for general sketching, we had enough information to pretty much understand what was happening. So that's the general idea. You can always do a little more with the concavity, but I had a feeling that just knowing the increasing and decreasing was going to be enough there. So if you need another example, let me know, or if you have questions on this one, please write in the comments and I will definitely answer your questions as soon as I can. Thanks.